All right, so these notes are going to kind of be 2 in 1 here. We're going to first talk about relationships. We talked about lines, pairs of lines cut by a transversal, and the 5 different kind of angle pairs that we now form. Now we're going to talk about the relationships when we have parallel lines. So when the 2 lines are parallel, we're actually going to have these different one of 2 different kinds of relationships. So here we're going to see, using the diagram below, we're going to go ahead and name the type of angle pairs of each of these, and then if they're congruent or supplementary. So congruent and supplementary are the 2 different relationships we're going to have. In this, we need to note that, remember, this means line PQ. Okay, remembering that from Unit 2, line PQ. This symbol right here means is parallel to. All right, and we'll say it is parallel to line RS. Okay, this has to happen for congruency or for angles to be supplementary. So we have to have these parallel lines. So we take a look. I'll probably do some zooming out here. We're going to take a look first at angle AEP. So we go from a reminder how we read our angles AEP. So looking at this angle right here. So I'm going to put a little mark here. I'm going to erase. And angle EFR. So we go from E to F to R. So looking at this right here. So we take a look at these 2 angles and we go, okay, well, we talk about the alternate or same side of the transversal. Well, I'm seeing that they're on the same side of the transversal. Now, interior, exterior, this is where we find one interior and one exterior. That means we have corresponding. We can't have the same side, interior and exterior. So we see here that the first angle is on the top left and the second one is on the top left. They are in matching or corresponding positions, so these are going to be corresponding angles. And what we're going to notice is they are both 110 degrees, meaning they are congruent. Now we go over here to angle AEP, so we're going still right here, AEP, and angle QEF, Q to E to F. So that middle letter is that vertex. We're going to see here that they are, here we're looking at more than just our angle pairs. We're sitting at one intersection, and that is it. It only involves 2 lines. That means we have 2 options. They're either a linear pair, forming a line, sitting on a line next to each other, adjacent, or they're vertical across the vertex. Here's your vertex. They are across the vertex from each other, so we have vertical angles. And we're going to notice this 110 degree on both of them, so they are also congruent. So all vertical angles that we've talked about are congruent. Next, we take a look at angle AEP, okay, because we're going to go ahead and stay there. Why am I erasing it? And angle PEF. So go from P to E to F. So now we're looking at these 2 angles. We're going to see that we're not involving both intersections again, so we're only doing one intersection. So we're looking at linear pair or vertical. These 2 form the line. They are on the line right next to each other, adjacent, line linear pair. And we've already learned about linear pairs, and we can also see here they are not congruent, but they are going to add to equal 180, making these supplementary. So now we're going to stick with angle AEP. Okay, that 110 that we've been using, and we're going to go to angle SFB. So from S to F to B, we're looking at this angle. So let's take a look at our transversal right here. Okay, line AB is our transversal. We're going to notice that they are alternate opposite sides. One's to the left, one's to the right. Alternate. So now we've got alternate. And here's that little interior in the road where the car is going to be driving. They are outside the road, safe, so they are exterior. Oops, EXTE. I'll put my angle symbol. And we're going to notice that their measurements are both 110, so that tells us that we have parallel lines cut by a transversal. Alternate exterior angles are congruent. The next one, we're still sticking with AEP right here. Okay. Now we're going to move to angle RFB. So we go from R to F to B right here. Look at our transversal. Are we on the same side or alternate sides? Well, they're both to the left. So they're on the same side of the transversal, but to the left. So we have same side. And the interior or exterior, we have exterior. So we have same side, exterior. And we're going to notice that we have different measurements. These two are going to add up to 180, making them supplementary. All right, we're getting away from AEP now. Let's take a look here. We're going to look at angle PEF. So from PEF, E is where that vertex is, PEF right here, and angle EFR. So right here. I'm seeing on my transversal right here where my pen is. They're on the exact same side, so we have same side. Let's check to make sure we don't have one interior and one exterior. I'm seeing that both of these angles are interior inside that road, making it the same side of the transversal, interior to the road, same side, interior. And we notice that they've got a 70 degree and 110 degree, which add to 180, so these are also supplementary. The last one, we're going to stick with angle PEF. So the PEF right here, that's 70 degrees. And now we're going to move to angle EFS. So right here. I'm seeing that on my transversal right here, I've got one to the left and one to the right. So they are on alternate sides. And they're both interior to the road, in alternate interior angles. And we notice that they are both 70 degrees, meaning they are congruent. So we take a look at this bottom section. It's saying angle pairs that are congruent. The angle pairs can be a little misleading because there are, those are pairs of two. We're not dealing with, but these are all 7 of the angle pairs that you will be dealing with in this unit, okay? So we're going to list all of our congruent. So here we saw that congruent. We had corresponding angles. Another congruent was vertical angles. Keep going. Another congruent was alternate exterior. Keep going. And the last one, alternate interior. Okay, so these are our congruent ones. Our supplementary are going to be the remaining 3. We look down the list. We go, okay, supplementary. We had a linear pair. Next supplementary, same side exterior. And the next and last one, same side interior. Sorry for the sloppy handwriting. I'm trying to make this as short as possible. Okay, so with this information, we're going to go ahead and start solving for angles. So let's take a look at the solving with parallel lines. Here, we're asked to solve for x. If the measure of angle 1 right here is 120, again, we're using erasable stuff so that we can erase these. We're going to use the same diagram for all of 3 of these. And the measurement of angle 5 right here is 20x. The first thing they're going to ask is type of angles. What of these 7 angle pairs are they? Well, we're involving 2 different intersections, so it's not linear pair or vertical. We're seeing that here's my transversal. I've got one to the left and one to the right. So we're on alternate sides, and we're going to look at some abbreviations here if we haven't already. Alternate, we just call it with an A. And here's the interior. And I'm going to notice that both of them are on the exterior. So we can put A, E, A for alternate exterior angles. So what does this mean about their angles? When we looked at the other page, we saw that they are congruent. So when 2 things are congruent, their measurements are equal. So we're going to set these up equal to each other. 120 is equal to 20x. We simply have one step to solve for x. We divide both sides by 20. It's been a while since we solved for x. X is going to end up coming out to be 6. That's all they asked for was solve for x. They didn't ask us to substitute in. Next, we're going to solve for x if, and we don't have to label all this one, but we're looking at measure of angle 7 is 4x plus 50, and the measure of angle 6 is 4x plus 10. So we look at 7 and 6. We're going to take a look at this transversal. They're both to the right, so they're on the same side. First, we've got to find out. It might be corresponding if they're on the same side, but we're going to notice that both of them are interior to the road, getting hit by that car. So So we have same side, SSIA, same side interior angles. When we looked on the first page here, we saw that both of our same sides are going to be supplementary. And the big thing that I tell my students is a bunch of S's. Same side supplementary, same side supplementary, supplementary. S's, okay? Your same sides are always going to be supplementary. So we're going to take both of these and we're going to add them to equal 180 degrees. Go ahead and write in here, supplementary. So we take our 4x plus 50, I'm going to write kind of small so I have enough room, plus the 4x plus 10, all equal to 180 degrees. To help any of those out, I'm going to draw my line here. Let's go find our like terms. I have a 4x here and a 4x here. They're going to add to give me 8x. I have a positive 50 and a positive 10 combined to give me a positive 60. Equal to 180 degrees. We're going to subtract that 60 from both sides. We'll have 8x equals, sorry, it's 120. I don't know what I was thinking. Just copying down 60 again. 120. Last step, let's get rid of that 8 by dividing. Again, we're only solving for x. So we divide 120 by 8. X is going to come out to be 15. All right, let's keep moving. This one we'll have to kind of move around. The next one here, we're going to take a look at angles 2 and angle 8. So up here, look at angle 2 and angle 8. Okay, I see I'm only using one of the intersections, which means I've got two lines intersecting, so I either have a linear pair on a line next to each other adjacent, or I have a vertical angles across the vertex. They meet right here at the vertex, across the vertex, so we have vertical angles on this one. So here we have vertical. And as we learned on the other page, right here, your vertical angles are congruent. And when two angles are congruent, their measurements are equal. So we're going to set these equal to each other. So we have 3x plus 20 equals 4x plus 10. All right, let's go ahead and solve for that x. We have variables on both sides. Let's go ahead and move that smaller variable. Let's move that 3x. This was subtracted from both sides. Let's bring down that 20 equals, well, when we have 4x's, we take 3 away. We have 1x remaining. And then bring down our plus 10. All right, get the 10 away from the x. So instead of adding, we need to subtract so they cancel. And then simply x is going to equal 10. We have 3 more problems to solve, making sure we get plenty of practice. A lot of things here. Our angles and also the just remembering how to solve for x. We're looking here at this diagram. We're looking at angle 2 and angle 6. So we have angle 2 and angle 6. These two are going to be on alternate sides of that transversal, opposite, alternate sides, one's to the left, one's to the right. And they are going to be interior to that little car vrooming down the road. So we're on alternate sides, interior to the road. So here I'm going to go ahead and write AIA for alternate interior, and I'm going to put a congruent symbol. So when two angles are congruent, their measurements are equal. So we have 80 equals that 20x. A lot like that first one we did, huh? All we're going to do is divide both sides by 20. That's in front of x. X is going to give us 4. Number 5, let's take a look. Number 5, we're going to be checking out angle 4 right here and angle 1 up here. I'm noticing that with my transversal, they're both to the left, so they're on the same side. We need to find out if they're same side, interior, exterior, or if they're corresponding. I'm noticing that they're on the same side, but they're exterior. Both of them are outside exterior. So we have alternate exterior angles. Sorry, they're on the same side. It's late on a Friday. So the same side of the transversal, exterior to the road. So we have same side exterior angles. So these will be supplementary. Remember, supplementary, that magic number is 180. So we're going to add these together to equal 180. So we have x plus 109 plus the other one, x plus 89, all equal to 180. Go ahead, combine our like terms. Here's a single positive x gives us 2x. We have a positive 109 and a positive 89. So this is going to give us a positive 198, all set equal to 180. We're going to get rid of that 198, get it away from the x, so we're going to subtract 198, and we're going to notice something happens on the right-hand side that's okay. Let's bring down that 2x, and let's go ahead and do that math. 180 minus 198, we're subtracting a bigger number, meaning we're going to end up with a negative, and that's fine. Okay? When we subtract that, we're going to wind up with a negative 18. Then we need to get rid of this 2. So that last step, we divide by that 2. So x is going to end up equaling a negative 9. And guys, it's okay if your x is negative. When you angles cannot be negative. Angle measurements cannot. But if you plug it back into x plus 109 and x plus 89, you're going to find out they will end up being positive numbers. The measurements will be positive. All right, sorry, we had 4 more. All right, next. Let's take a look here. We've got these 2 angles. We're going to notice that they're on the same side. They're both to the right. But looking at interior and exterior, cars just keep looking better and better. One is in the road, one is out of the road. It means it's not same side interior, it's not same side exterior. We only have one more option with same sides, and that's going to be your corresponding. They are in matching positions. Bottom right, bottom right. So here we have corresponding angles. And we learned that these are congruent. They're exactly the same size. So we'll set these equal to each other. 23x minus 5 equals 21x plus 5. I encourage you at this point, pause it and work it out on your own. Make sure that you remembered how to solve for x, and then resume and make sure that you did the right steps and you got the right answer. So let's go ahead and move that, the variables first. Let's go with the smaller one. So subtract that 21x from both sides. Cancels over here on the right. We end up with 2x minus 5. Bring down the minus 5. Equals, we only have a positive 5 over here. Now we need to get that negative 5 away. We're going to add to both sides. Bring down our 2x. To right, we now have a 10. Last step, divide by 2. 10 divided by 2 will give you 5. Now it did say also to determine the angle measures. So what we need to do, since these are congruent, you only need to plug into one of them. All right, so let's see what that looks like. We're going to just go ahead and take any one. I mean, I like the one with the smaller variable. So I'm going to take the 21x plus 5. I'm going to remove x, and I'm going to replace it with what x is, 5. When I plug this into the calculator, I'm going to find out that both angle measurements are 110 degrees. They are the same, so and you know what? Plug in 5 into 23x minus 5. You're going to get the exact same 110. All right, our last one here, we're going to take a look at, we got this 80 degrees right here. We have the 11x plus 1. We notice, oh, guys, hey, we're not involving this intersection. So again, with 2 lines, we either have a linear pair or vertical angles. Are these next to each other on a line, adjacent on a line, or are they across the vertex from each other? Well, I see them sitting right here adjacent next to each other on that line, meaning we have a linear pair. And that linear pair, we remember, is going to be supplementary. So adding to equal 180 degrees. So we remember that in 2 things are supplementary. We're going to add them to equal 180 degrees. So I'm going to take that 80 plus that 11x plus 1, all set equal to 180, that magic number. First things first, let's go ahead and combine our like terms. I notice here I have a positive 11x, but I don't have any more x's to add with that, so we're just going to bring 11x down. Here I've got a positive 80 and a positive 1, giving me a positive 81. Bring down your 180. Let's get rid of that 81. It's adding here, so we need to do the opposite and subtract. Bring down our 11x equals 180 minus 81 is going to give us 99. Nice little easy to divide by 11 now. X is going to come out to equal 9. Now again, it wanted the angle measurements as well. Well, we already know what one of them is. It's 80, right? So no big deal there. Let's go ahead and take this 11x. Put it right here. 11x plus 1. Let's remove x. Let's put in what x is. 9. We'll wind up with 99 plus 9. Sorry, that should be a 1. I was thinking 9. There we go. So we have 11 times 9, which gives us 99, plus 1 is going to give us 100 degrees. And you could have just subtracted 80 from 180 also, knowing that both of them add 180, but I wanted to practice substituting them. Right? So there are your different angle pairs with parallels, congruent, with parallel lines, looking at what's congruent, what's supplementary, and remind us how to solve for x. Please ask your teacher if you have any questions or need any clarification.